In this video, I'll be solving the second part of fourth question of UPSC Civil Services Mains 2021 Statistics paper 1. So we are given f of x comma y, the joint density, as e to the power minus yx square by 2 into y to the power 3 by 2 into e to the power minus y by square root of 2 pi for minus infinity less than x less than infinity and y is greater than 0. And we have to obtain the marginal distribution of y and conditional distribution of x given y. And we also have to find the expectation of y, variance of y, expectation of x given y, variance of x given y. And by using that, we also have to find expectation of x and variance of x. So for that, first we can observe one thing here. So if we consider integral e to the power minus yx square by 2 dx. So that is nothing but, so if I consider root yx as t, so root y dx would be dt. So dx is dt by root y. So this integral e to the power minus yx square by 2 dx is integral e to the power minus t square by 2 dt by root y. So which is nothing but, so if I multiply by root 2 pi, so 1 by root 2 pi e to the power minus t square by 2 dt. So that is nothing but root 2 pi by root y, and this density will go to 1. So that means this integral is nothing but root 2 pi by y, because it's a standard normal integration of the standard normal density, which is 1. So that means if I consider the marginal density, so we can first find the marginal density of y, which is fy of y, which is integral minus infinity to infinity f of x comma y dy. That is nothing but integral minus infinity to infinity y to the power 3 by 2 e to the power minus y by square root of 2 pi into this e to the power minus yx square by 2 dx. So that is nothing but y to the power 3 by 2 into e to the power minus y by 2 pi into integral of minus infinity to infinity e to the power minus yx square by 2, and that we have already found as square root of 2 pi by root y. So square root of 2 pi into square root of 2 pi by y. So that is nothing but y to the power 3 by 2 into e to the power minus y by y to the power 1 by 2, which is y into e to the power minus y. So that means the marginal density of y, so fy of y, is nothing but y into e to the power minus y, and y is greater than 0. So that means this is following gamma density with alpha as 2 and beta as 1. So that means fy of y we can rewrite in gamma form, y to the power 2 minus 1 e to the power minus y by gamma of 2, so for y greater than 0. So now we can find the conditional density. So the conditional density of x given y is equals to y. So that is nothing but f x given y of x given y, that is f of xy, the joint, divided by the marginal density of y, which is y to the power 3 by 2 e to the power minus y into e to the power minus yx square by 2 by square root of 2 pi whole divided by y into e to the power minus y, which is square root of y by 2 pi e to the power minus yx square by 2 and minus infinity less than x less than infinity. So that means this is nothing but 1 by, so we can see this as 1 by root 2 pi into 1 by y into e to the power minus x square by 2 by y, or 1 by 2 into x square by 1 by y. So that means this is nothing but a normal density. So x given y is equals to y follows normal with 0 and variance is 1 by y. So that is the conditional density of x given y, and so that's a normal one, and the conditional density, the marginal distribution of y or marginal density of y is following a gamma distribution with gamma, alpha and beta, with alpha as 2 and beta as 1. So now if y is following, so if y follows gamma 2 comma 1, that means expectation of y is nothing but alpha times beta, which is 2 into 1, which is 2. And the variance of y is alpha beta square, which is 2 into 1 square, which is 2 again. And x given y is equals to y follows normal 0 comma 1 by y, which means expectation of x given y is 0 and variance of x given y is equals to y is 1 by y. Now we can use the Tower property of conditional expectation. So expectation of x is nothing but expectation of x given y, which is nothing but expectation of 0, which is nothing but 0. And using the law of total variance, we can write variance of x as expectation of variance of x given y plus variance of expectation of x given y. So that is nothing but expectation of 1 by y plus variance of 0. That is nothing but expectation of 1 by y. Now y follows gamma 2 comma 1. We need to find expectation of 1 by y, which is integral 0 to infinity 1 by y into e to the power minus y dy, which is integral 0 to infinity e to the power minus y dy. That's nothing but 1. So that means expectation of x, which is expectation of x given y, expectation of x given y, which is expectation of 0, which is 0. Now variance of x is expectation of variance of x given y plus variance of expectation of x given y. So this we got it as 0 and this we got it as 1 by y, and expectation of 1 by y we got it as 1 plus 0, which is 1. So the expectation of x is 0 and variance of x is 1. So that's it for this video. We'll meet in the next video.